if you follow network neutrality principles, etc., a resolver must send back to the user what it got from the authoritative servers. So resolvers can be provided by your access network, by your company, or you can use a public resolver. Everyone knows the Google public DNS. Now, if I want to censor, if I want to block people from visiting this website, for instance, and if I want to use, I may use a DNS, but there are, of course, many other ways to block. If you want a partial list of the techniques that can be used, you just have to read RFC 7754, which is a very comprehensive survey of filtering and censorship on the internet. Really recommended reading. Of course, most people here are technical people that tend to focus on technical issues and technical solutions. But remember that if you want to censor, you also have non-technical solutions which are quite efficient. For instance, banging people on the head with something very hard is an efficient censorship technique. So when people say, oh, it's not a problem if there is censorship on the internet, I will use an encrypted VPN and things like that, in some countries, it can be really dangerous. So where to attack the DNS? Because there are two types of servers, authoritative name servers and resolvers, there are two ways to attack the DNS. One is to take down the domain. It works only if you have the power over the registry or registrar. A typical example, for instance, is Sci-Hub, the Pirate Bay of scientific research. The takedown of the domain scihub.io, for instance, prevent anyone to go to Sci-Hub, except if they do some specific manual configuration. So this is the most efficient technique because you can completely destroy a domain or redirect it. For instance, in the case of the inner sites, the domains are actually redirected to a page explaining that that it was I don't know, sites infringing intellectual property or things like that. But this works only if you have control on the registry. If you want to censor things in Brazil, if you want to censor a .com domain in Brazil, you don't have the control of the registry. You have to rely on something else, which is attacking the resolver and asking the resolver to lie, to give, to break the rule that the resolver has to relay faithfully the result to the users. Instead, when you have lying resolvers, the resolver deliberately gives another reply. There are several ways to do that technically. For instance, if the resolver is bind, you can use RPZ. RPZ can be used for many things, but the idea is that you can have a policy which takes precedence over the data sent by authoritative name servers. If you use Power DNS, in Power DNS you can add Lua scripts and at hooks in every place in the DNS resolution process. So this script can do whatever you want, or more exactly, whatever you can program in Lua. And once you have decided to have lying resolvers, you can decide either to give an error code or to redirect to something somewhere. If you want to have a complete view of DNS filtering and the issues that it raises, there is a very good report of AFNIC Scientific Council. Disclaimer, AFNIC is my employer, but I was not involved in this report. So when I say it's excellent, it's really excellent. So one word about the legal framework. In many countries, when you want to censor, you need to have some sort of legal backing. The important point is not the exact list of laws, decrees. It's to emphasize that in some cases, the law is very general, is very neutral about the technique to use. It just says something like internet providers, whatever it means, have to prevent access to this website. But in other cases, the law or the decree explicitly mentions the DNS. For instance, the decree of 2011 in France about illegal gambling sites explicitly mentions the DNS, so censorship has to be done with the DNS. Same thing for the terrorist site, the decree of 2015. The text in French, I will not attempt to translate it because even in French, it's completely impossible to understand it. It's a complete mess, but you will note that there is DNS in it. And of course, you can have court order. Typically, court order in a country like France, court orders are less precise than law and decrees about how to implement the censorship. It just says it has to be censored. And of course, you can find many similar cases in many European countries. Actually, it's only a minority of countries without DNS censorship. In the case of North America, the main example I have is Law 74. Actually, it's not yet a law, if I understand correctly. It's under discussion in Quebec about illegal gambling sites. Illegal gambling sites being any site which is not the official one. And it's planned currently in this law to have, again, a DNS censorship for this gambling site. It's actually under discussion. If there are people from Quebec here, we can talk about that. Now, how to measure the extent of censorship? I mean, in theory, it is done, but what it is in practice? The problem is that you cannot measure anything, you cannot measure from any vantage point using DIG. Typically, the idea of the DNS is that you have the same reply from anywhere. So you can use DIG or any other DNS client on your local machine, and you will see the same result everywhere. But it's not the case with censorship because, of course, it depends on the country. So you need to have access to a remote resolver. If you want to measure censorship in Turkey, in Bulgaria, in Ireland, you need a resolver in Turkey, Bulgaria, Ireland. At the time, all the DNS resolvers were completely open and anyone could send a request to anything. It's now regarded as bad practice because it allows reflection attacks using the DNS. So now, good resolvers, because of RFC 53, 58, good resolvers are no longer open. So you need to use something else. I used Wipe Atlas probes. For those who don't know, there are small hardware probes that volunteers install on their network. And the probes connect to the master at the Wipe NCC, and then the master can instruct the probe to perform measurements. In a way, they are a botnet, but a good botnet, a nice botnet. So they can do ICMP echo, trace routes, and important for us, they can do DNS, and with a lot of options. You can change a lot of things in the DNS request. And also these measurements are not done, decided by the WIPE NCC, but any user of the WIPE Atlas system can decide on its own measurements and can tell the Atlas probes, hey, let's try to resolve nanog.org and see what happens. I use for this a tool, Atlas Resolve, which uses the Atlas API to ask the Atlas system to run DNS requests on N Atlas probes. For instance, here is a use of Atlas Resolve. -R500 means I want 500 probes. It's actually the maximum that an unprivileged user can request. You can select probes by AS number, prefix. Prefix doesn't work very well, but it's still possible. And by country, which is very important in our case because typically censorship is country specific. So here I request probes in France. The domain name fifostream.tv has been banned by a French court order in 2013. It's related to file sharing, something like that, or illegal streaming, I don't know. So you can see there are 4 possible answers to these probes. First case, and the most common 408 occurrences, is the real IP address. There was 1 probe getting a server failure, 10 getting NX domain, and 72 probes got localhost address. So localhost and NX domain are 2 different ways to lie. Both are lies. The real address is the first one, the one starting with 52. But localhost or NX domain, no such domain, is a possible response because the court order did not specify what sort of lie to send back. We will see later that in some cases, censorship mandates a specific answer. Also, censorship decays with time. The court order was made in 2013, and at this time, there were something like 50% of the Atlas probes in France who saw the censorship. Now it's 15%, something like that. Because many people who implemented this court order had some sort of timeout system that made that after a time, it was automatically or manually removed. Sometimes it's the opposite. Some people don't maintain their list, their blacklist, and sometimes censorship stays forever, even if it has been repelled by another court order or thing like that. So also you can see that it's far from 100% in that case, but it's always the case. Except if you are ready to take harsh measures, such as putting people in jail and things like that, DNS censorship is never perfect. Second example, it's because, okay, I've seen problems, but maybe these problems here were because of technical problems, broken name servers and things like that. So it's always necessary to compare with another country, in that case Canada, and I can see in Canada no NX domain, no localhost address. So typically the problem, the censorship, is really specific to France. The self-fail can be a routing problem. In the case of this domain, all the name servers are in the same AS, which is bad practice, and worse, in the same /14, so any routing problem can take down all the servers, which can explain the self-fail. But censorship itself is country-specific, so the localhost or NX domain are DNS lies. That cannot be something else. Another case recent is the case of WhatsApp censorship in Brazil. You've heard about it. For a judge in Brazil ordered the Brazilian ISP to censor WhatsApp. It was done through the DNS. So here you see that among the Atlas probes in Brazil, 10 of them saw a reply that was NX domain, no such domain. It didn't last because very soon the court order was repelled. And you can see that 24 hours later, all the Atlas probes in Brazil saw the correct answer. The time is very important because, of course, censorship varies with time. That's why the Atlas Resolve tool displays the time of the measurement. Important note about the WIPE Atlas probes, something which is important to keep in mind, is that they are installed by volunteers, which means that typically they are probably in networks which are more geek than the average. For instance, they probably use DNS. For instance, 1/3 of the WIPE Atlas probes have IPv6 connectivity, which is certainly more than the average. I don't remember the number, but more Atlas probes have a DNSSEC validating resolver than the average user again. Also, probes, because they are installed by volunteers, in some countries, you don't have a lot of them. For instance, there are only 4 probes in Taiwan, which does not reflect the size of the country or the deployment of the internet. And only 8 in Mexico, so if you can install a probe in Mexico, it would be very useful. So because of that, it's very important not to jump from the percentage of Atlas probes to a percentage of user. If I say that 50% of Atlas probes see the DNS censorship, it does not mean that 50% of the users will be blocked. It's complicated to go from the number of probes to the number of users. Another thing that was not done on the first case is DNS lies can be used to redirect to another site. Here is an example on Turkey. This website distributed information which displeased the local government. So there was an order to redirect to another site. 2 first addresses are addresses of a local ISP with a website, with a message, you try to access something illegal. Only the last 20 occurrences, so the address starting with 176, are real. They are the real address because people were using an ISP which didn't implement censorship or for other reasons that we will see later. An important thing is that if you are redirected, it means that the website that you connect will get your source IP address, and because of the host header of HTTP, they will know what you were visiting. In the case of France, for instance, it's the case of the site who do terrorist propaganda. The DNS slice, in that case, redirect you to a web server, to an HTTP server of the police, which will know that you try to visit a terrorist website. Another example here in Malaysia, more or less the same. One point, by the way, is that measurements themselves can raise ethical issues. It's actually, currently, it's something which is discussed a lot in the world of network researcher, because measurement of this sort of thing, which are very sensitive, can sometimes spell trouble for the user. Imagine, for instance, that I run measurement for www.porn.example, and if there is an Atlas probe in Iran, and if someone is watching what the probe is doing, the people hosting the probe can be in trouble. So this is something to keep in mind. It's not really a problem in a country like France, but when you investigate in a country that you don't know, where you don't know exactly what the people are risking, it can be a problem. Also, to have a bit of fun, Atlas Resolve can request the probes to do measurements for other types, for instance, AAAA. By default, it's A, IPv4 address. AAA is IPv6 address. This domain is censored in France for terrorist propaganda. So most of the time, most of the probes got an empty answer, which is normal. But there are some providers that manage to redirect to localhost, the IPv6 localhost. So you can have censorship with IPv6 as well on the DNS. Other measurements, well, this is to show that it can be the case in many other countries, nothing really important in the case of Ireland. This one is more complicated. It's in Indonesia, where Reddit is censored. In the first case, I ask probes in Indonesia, and I get a lot of different responses. The only real one is the last one, the last with the addresses starting with 198. Everything else is a lie. An obvious solution when you have a lying resolver, or when you suspect a lying resolver, is to use another resolver. In the second Atlas resolve command, I use the -e option, and -e asks the Atlas probe to use, instead of the default resolver, which is typically learned by the probe through DHCP, instead of the default resolver, use a specific resolver, not Google Public DNS, because every sensor on Earth knows about Google Public DNS and can block it or hijack it, as it was done in Turkey, for instance. So in that case, I use another public resolver, the one starting with 80, and then I can see that some of the lies disappear, but not all. Which means that in the case of Indonesia, there is not only lying resolvers, but there is also some probably port hijacking. Traffic going to port 53 of this resolver was redirected to a lying resolver. So it can be complicated, and be careful before jumping to conclusion, because very often I have seen people on public fora saying things that, yes, this censorship is done by DNS, just switch to Cisco Open DNS and it will be solved. No, it's more complicated than that. You need to investigate first. Also, not every glitch is censorship. A typical example was the problem of NASA in 2012 when NASA managed to make a mistake with DNSSEC, and validating resolvers like the one of Comcast failed because of that. That was the point of DNSSEC. Many people on public forum, such as Reddit and things like that, or Slashdot, noticed that it was specific to Comcast, and there were a lot of messages with titles like Comcast block NASA, which is completely false. But remember, things are complicated, the internet is complicated, many people who express themselves on the social networks are clueless, so always keep your head cool and think before you participate to this sort of discussion. Now, because everyone here is technical, many people here already think while I talk about solution, workaround. For instance, you can move to another name, like the Pirate Bay is always doing. The user can switch to a local resolver on his own machine or to a public resolver. It's not easy because public resolver can be hijacked, and it already happened typically with Google Public DNS in Turkey. There is a route for 8.8.8.8/32 in many routing protocols in the world. So it's not a perfect solution. You can also use a Tor, you can use a VPN. DNSSEC itself can detect censorship. It does not solve it, but at least it makes it explicit. But up to now, all the domains that I have seen censored were not signed with DNSSEC, so I have not been able to see what happens with DNSSEC. And of course, if you like high-tech solution, everybody these days is talking about the blockchain. So you have several blockchain-based solutions, such as Namecoin or Blockstack or the new Ethereum name service, which is vaporware today, but may happen one day, which will allow people to resolve name into addresses in a way which is much more difficult to censor. But today, the ordinary user, Mr. Smith, uses the DNS, and censorship is a problem for him. But in the future, we will see probably that applications will have to rely on this sort of thing. We'll have to embed new ways to resolve name. I've read on an article someone who said that applications today must behave like botnets. They have to find new tricks to resolve names because they will have to work in a hostile environment because of censorship. So all these workarounds are brittle. A typical example is that a public DNS resolver is very easy to spoof. They also make a difference between Mr. Smith and the geek who is able to do this. Most of these solutions are not for the ordinary user, unfortunately. So in summary, censorship is not complete. As you have seen from the measurement, there is never 100% success of censorship. There are always workarounds. But most of the time, the authorities don't care because they don't ask for 100% success. Sometimes they just want to make a point. Sometimes they are happy if the ordinary citizen is censored and they don't care about the rest. And also, one more political problem is that because of censorship, to see some websites which are very useful, such as Sci-Hub, for instance, you need now to be an engineer, a network engineer. It's certainly a problem about democracy if freedom of speech, ability to access whatever content you want is reserved to the people who participate to the NANOG meeting. It's not good. So in the future, I'm afraid, whether I like it or not, I'm afraid that the tussle will continue forever because people will find workarounds against censorship, then censorship will become more efficient, then people will find other workarounds, etc., etc. The net result is that name resolution, which has been something very robust, very fast, very efficient, will become more and more messy, complicated, and we will have more and more problems debugging it. Thank you for your attention, and if you have questions, it's better, of course, if you ask them in French, but okay, you can try in English if you want. Okay, then.
Any questions? All right, thank you very much,
Okay.
Stefan.
Next.